Hey everyone, welcome to video 6. We are going to be exploring interval vectors today. You're going to need handout 6 and a pencil. Now, a couple of weeks ago, we learned about interval classes, which we abbreviated as ICs. And those we discussed as simply a way of labeling how many semitones are in an interval. So this little chart here is recreated from a previous handout, but you see that minor second has 1 semitone, so we call that interval class 1, all the way up to the major seventh, which contains 11 semitones, and we call that IC 11. Now we're going to reduce this table. And to do that, we're just going to take interval inversion into account. So every interval is going to be paired with its inversion, and they will get the same interval class. So you've got your minor second and your major seventh, both being considered IC1, major seventh and minor seventh, both considered IC2, etc. Now, what that does is halves our number of interval classes. We went from 12 down to 6. And that brings us to our topic for today, which is that of the interval vector. Now, I know we've been doing a lot of stuff that sounds like math, and this one still does. So let's talk about what an interval vector is. It's a string of numbers that shows you how many times each interval class appears within a set of pitches. Now, the reason this is important is because the intervallic content of a collection really contributes to the character of that collection. If you think about the interval collection that would be contained, say, in a whole tone collection versus the interval collection that would be contained in the octatonic collection, there's going to be a distinctive absence of a lot of intervals in the whole tone collection because it only has whole steps and their sort of multipliers, versus the octatonic collection where you have alternating half and whole steps that will create a very different intervallic content and a very different color palette. So that's why interval vectors are important. Now, when you see an interval vector, it's going to appear in angled brackets. I know we've been learning a lot of different bracket types. Here's another one. So your interval vector is going to appear in these angled brackets, and it's going to be a string of 6 numbers, one number corresponding to each interval class. So even if an interval class has no content in a collection, you're still going to see a 0 there. But it's just going to be a string of numbers. I'm going to use arbitrary letters just to stand in right now. But a string of 6 numbers enclosed in those angled brackets. So how do we go about finding an interval vector? I have set class 0145, one of its members, notated on the staff here. What we need to do is find the interval class between every pitch and every other pitch. So not just going kind of left to right, but exhausting every possible interval in the set. And there's a really methodical way you can go about that. And I'll show you the way that I process this. So I start with the very first pitch. And I find the first interval. So F to F sharp, it's a half step that gives you IC1. And then I stick with that first pitch and I just keep kind of expanding out to the successive notes. So now I'm going to go from the first pitch to the third pitch, F to A, and you have your little chart up here. F to A is a major third. So that gives us IC4. And then I'm going to go from the first pitch to the very last pitch. F to B flat, perfect fourth, gives us IC5. Now I've exhausted all of the intervals from the first pitch of the set. Now I'm going to do the same thing from the second pitch. So now we're going F sharp to A. That gives us a minor third. That's IC3. And then F sharp to B flat gives us IC4. Now we've exhausted all the possible intervals from the second note. Last but not least, we're going to go from the third note. We only have one interval left. A to B flat is a half step, gives us IC1. So now we have calculated every single interval class that is possible in this set. Now, just by looking at it, you can see we have way more interval classes than we do pitches. And that's what you're going to see. That's what you should expect. Now, to get the interval vector, you have to tally up how many of each interval class you have. Now, you might be able to do this in your head. I do not trust myself to do it. So I actually literally write out a little tally score sheet as I'm working to keep track. So now I'm going to start from down here and just go left to right. I have an instance of IC1, IC4, and IC5. And then I've got these three up here. I have an IC3, another IC4, and an IC1. So that means if I tally those all up, that's my interval content for this set. Last step then, put it in some brackets. 2, 0, 1, 2, 1, 0. Close your brackets and you are done. Now, looking at this interval vector, it shows you a couple of interesting things. One is that the interval content is pretty well dispersed. We don't have any interval that jumps out as kind of the most prominent. And the other thing it shows us is the absolute absence of two interval classes. We have no IC2s and no IC6s. And that, of course, will have implications for the sound of the set itself. Okay, now go ahead to the back of the page or second page on your tablet. And I have two for you to try on your own. Now, I gave you staff paper for you to notate anything that you like, as we did on the first page there. For this second one, I ask for any member of set class 0136. Now, you and I might then end up with different notes because any set class can contain a finite number of repetitions starting from different pitches. So you and I might have different notes, but we should come up with the same interval vector. So go ahead and work these two out and then come back and we will check our work. Okay, so let's see what you came up with. This first example with PC set 267T. Remember that pitch class sets in those curly brackets tell you the actual notes on the staff. So we should have the same pitches, D, F sharp, you might have G flat, G natural, and A sharp or B flat. Any of those enharmonic equivalents is fine. And from there, you exhaust all of your interval options. One of the trickier parts of this is when when you go from the first to the second pitch, you have a very clear interval class 4 with that major third, right? And then you get an IC5 with the perfect fourth there. Then from here to here, whether you have it written as an A sharp or a B flat shouldn't matter. You can flip over to this chart if it's more helpful, but let's say B flat because it is easier. D to B flat is a minor sixth, which puts us in this box of our chart, which means we have another IC4. So you get an IC4 in its small version, in the major third version, and then we get another IC4 from the same pitch, but in its inverted or larger version. So I know that can be kind of confusing when you see it for the first time. And then I've got IC1, an IC4 here, and an IC3 here. So if you did your little tally like I did, or however it is you came up with it, you will see that you have an interval vector of 1, 0, 1, 3, 1, 0. Again, and this was completely by chance, we have an absence of IC2 and IC6, and the vector shows us that. But we do have a kind of dominant interval in this tetrachord, whereas the last tetrachord that we did on the first page, all of the intervals were populated at 1 or 2 instances. This one, we have a predominant interval in IC4. And that, again, will change the sound of the tetrachord. Okay, last but not least, we have set class 0136. And like I said, we might all have different notes for this. I chose to start my set class on E. Now, if you were wondering how you even kind of come up with this, I'm assuming that a lot of you notated yours as C, C sharp, E flat, and G flat, or it's enharmonic equivalence. That's the easiest way to notate a set class when it's given to you, is to just start the darn thing at C and basically treat this as if it were a PC set and use the actual set class numbers to draw off of the clock face. That's totally fine. That's probably the most logical and the most error-proof way to go about this. Now, I decided to start mine on a different pitch. If you're wondering sort of how to navigate that, you can start a set class on any pitch. So I started mine on E, and then I just used the set class to inform how many semitones I needed to go from that pitch. So 0 to 1 gave me F. 0 to 3, okay, I need to go up 3 semitones from E. That'll give me G. And then 0 to 6, I need to go 6 semitones or a tritone up from E. That gives me B flat. So that's just a quick review of how to derive a cluster of pitches from a set class. Okay, anyways, let's look at what we have then. Like I said, no matter what pitches you have here, we should all have the same interval vector. So starting from that first pitch, we get an IC1, we get an IC3 and an IC6. That is very obvious from the set class itself. So all of your interval classes from the first pitch should match the numbers in the set class. Then you've got to figure out the internal intervals. So we get our IC2 at last. And then also from the second note, we get a perfect fourth, which is an IC5. And then last but not least, we've got that last internal IC3. I've got my tally over here. And that turns into this interval vector. Now this vector looks very similar to the one we have on the prior page, where it's just a lot of 1s and 2s. The difference is we only have one sort of null interval, 1, 0 in this vector. So the intervals then are a little more widely dispersed, which again gives us a varied color palette. We have no instances of IC4 this time. This last one, we had tons of them. This one, we have no instances of IC4. So what does that tell us about the sound? How might that affect the sound? And we do at last get some IC2 and some IC6 in there. Okay, there is a worksheet for you if you would like to hand that in for class on Wednesday. There's also pre-listening to a Schoenberg piece that we are going to spend the entire week on. So in class on Wednesday, we're going to do some practice with vectors in small groups. And then we will take a crack at the Schoenberg for our first day with it. And then Friday, we'll wrap up the Schoenberg. One note about the piece, don't go in there trying to find interval class vectors. This lecture is slightly divorced from that piece in particular. It's something that you need to know soon, and this was sort of the most logical day to do it. But don't let that kind of skew your listening or your preliminary analysis of the piece. It's a very different piece for us, and I'm really excited about it, but you can sort of file away interval vectors in the back of your brain while you're listening. All right, wonderful, guys. I look forward to seeing you on Wednesday.